and the impact she had on us all. So to start today, Dr. Deborah Money, the head of the Department of Obstetrics and Gynecology of University of British Columbia, will say a few words and provide a land acknowledgement. Thank you.
Thanks, David. Can people hear me okay? Yeah. So it's really my very great pleasure to welcome you here to what we hope is just the first of this annual lecture in honor of Dr. Nellie Auersberg. So to start us off in a good way, I just want to acknowledge that we're here hosting this lecture from the traditional, ancestral, and unceded territories of the Coast Salish peoples, the Musqueam, the Squamish, and the Tsleil-Waututh. And we're very pleased and grateful on this beautiful sunny day to be here. So I have a personal pleasure in seeing that this event has come to fruition. Nellie was a member of the University of British Columbia for many, many years and started off, and I know we're going to hear more about her, started off in anatomy, but did end up in obstetrics and gynecology. And I would suggest that perhaps she was not entirely as appreciated as she should have been in her career, perhaps because she was a woman scientist. And I think this is really wonderful to acknowledge her great achievements. I did get to know her a little bit because we were actually 2 doors apart with our offices at the BC Women's Hospital when she moved there to continue her work. We would bump into each other and have a chat in the hall, but I was always so impressed that she was there every single day, and the door was open and many, many trainees would come in and out, and I would see her actively engaging in energetic conversations with the various trainees. So it was really a privilege for me when I was the director of the Women's Health Research Institute to work with Nellie as we established the Nellie Auersberg Award as part of a BC Women's Research Award. She was extremely modest about things at all times, but was always encouraging of others in their research aspirations. So I'm pleased that this lecture will serve to shine a light on her work and her legacy, and very, very pleased to see the first speaker here. So I will hand off for introductions.
Thank you so much, Dr. Money. So one of Dr. Auersberg's amazing legacies is the incredible trainees, many of whom are leaders in ovarian and other types of research around the world. And just for fun, if those who worked with Nellie or were mentored by Nellie, if you put up your hand on Zoom, I think people will be impressed by how many of her ex-trainees and collaborators are joining us today. One of her PhD students who's been stunningly impactful in our community at University of British Columbia is Dr. Cal Roskelly, and he's kindly agreed to tell us a few words about Nellie for the students who may not have had the privilege of getting to know her personally.
Great. Thanks, David, and thanks, Dr. Money, and thanks, Maria, and everyone for putting this together. And I see everyone online there. I can see Pat Kruk in Florida, and Alice in Hong Kong, and Gordon in Portland. And Santo, you're there, I think, and I presume, Santo, you're still in Florida, and Trevor, and all kinds of other folks. And there's Pat. We can't see on the screen here, but Dr. Cook's here. All folks that were, as well as many people in the room that have worked with and trained with and collaborated. I promised myself I wasn't going to get verklempt, Maria, but I may a little bit. Whoops. So let's go. So, for this lecture, I have the same picture up that Jurgen and David have. This is a pretty famous picture now because UBC uses it a lot. But for folks that worked with Nellie on the UBC campus, they recognize this room. And Sarah, I believe this is the room next to the virus room with the little windows where we had the scope. The thing about working with Nellie was she was so unbelievably intellectually curious. And when you came to work with her or train with her or collaborate with her, as Torsten knew even as an undergraduate, the ideas just flew back and forth. Things were wide open. As long as you had a good idea, she was going to let you work on that idea if you could really work it out and explain it with scientifically rigorous. However, just like at home with her kids, Maria and Eddie, and her husband, John, she had expectations if you worked with her. And the expectation here that shines in this picture is not the scope, not the backdrop, it's Nellie's left hand. Nellie's left hand is cupping a T25 flask of who knows what, because Nellie was a cell person. And she was a cell person at the start, as you're going to see in a second, and she was a cell person at the end. And everything in between was developmental biology. So it always came back to what was happening during development with these cells and how could they be modified when they became tumorigenically or oncogenically transformed or progressed. And the thing was, the expectation was she knew what every dish and every plate and every flask and every, Michelle's smiling as well, and Clara and Sarah, in the incubators, and Torsten, and in the LN2, and I'm sure Pat's doing the same thing. Santo, maybe not so much. Gordon, who received her cells, same thing. She'd probably want to know what passage you were using the cells at, Gordon, and how you'd culture them and what % serum, and whether it was horse, and there's no such thing as fetal calf, it's fetal bovine. She would want to know all that stuff. She was really exacting with the cells. That's what she did. Where did the developmental biology come from? Well, as Dr. Money pointed out, Nellie spent a long time at UBC, and before she was in the anatomy department as a faculty member, she actually did a PhD in zoology. She worked with a guy named Cy Finnegan. This is the front page of her thesis. And you can see from the title, she was working with cells and she was thinking what they were doing. Tumor histogenesis, she was really looking at differentiation states. She did a lot of ultrastructure, figuring out what a bunch of cells she'd already made between finishing medical school, as you can see there in 1955, when she had to go to Seattle, because Dr. Money's point, I think she had a difficult time entering medical school here in Vancouver. So she went to the University of Washington. She came back, got married, I think, or was she married already? She was married to John. She had to stay in the nurse's residence for residency. John was only allowed to visit her if he kept both feet on the floor and all that kind of stuff. But in between, she worked in the cytology lab at Vancouver Hospital. She worked at the BC Cancer Research Labs, which were on campus at the time. And man, she was publishing. Oops, I keep hitting the wrong button. This is just a few of the papers that she published between her MD degree and between her PhD. One thing you'll notice is there are 3 single author Nature papers. She was really making the cells, and what she was doing was she was developing protocols to actually do primary passage culture of various tumor types, starting, I believe, Sarah, with cervical. I think it was the Cs and C4s, and modifying to see what they did. She was really developing the tools that so many people in this room later used, so many people online, so many people in Canada, so many people across the world used. And that was often the starting point for the collaborations, but then this intellectual curiosity working with people is what kept the collaborations. And I'm sure Santo and Gordon would agree on that. Quite amazing, but always thinking of developmental biology in the context of development as well. Okay, Jurgen's going to talk way more about this in a moment, but the thing, I didn't even talk about all the different cell types, moving from those human tumor lines to normal rat kidney cells to transforming all kinds of granulosa cells, adrenal cortical cells. She used the RAS oncogene a lot. And then she started to work with ovarian surface epithelial cells, and initially wasn't human. She worked with rat cells. So in the lab, they were called Rose cells. And then Pat Kruk came to the lab and she started working with human ovarian surface epithelial cells, or OSE cells. And that's the little guys that would be on the surface of the ovary. You'll notice right next to them are these tubes, the fallopian tubes, and these little catcher's mitt fingers that are going to catch the oocytes when they're released, the fimbriae. And they're all lined with an epithelium. And this is going to be the whole context of what you're going to hear about today. But initially, Nellie really concentrated on these ovarian surface epithelial cells and looked to see what would modify them. So this next one is just an image that she published about 10 years ago, where she was really where once folks across the world, like Jurgen and folks like Diane Miller here today, really were figuring out clinically that the worst types of ovarian cancer didn't actually come from these surface epithelial cells all the time, but clearly in a great majority of the time with these terrible tumors, these high-grade serous ovarian carcinomas, probably coming from the epithelium on these little catcher's mitt cells that line these fimbriae. And you're going to hear Jurgen talk all about that today. Clinically, it was being really demonstrated first, I would think, and now experimentally we're just catching up. Nellie's point was, that were the surface epithelium of the ovary from this little part here. They're right next to the fimbriae. And in the last few years that she worked, she wanted to, how similar were those cell types? So these are some stains from a paper she published in International Journal of Oncology, one of her last papers, where she was looking at stem cell markers on those ovarian surface epithelial cells on the left and the fimbriae cells on the right. This is nanog at the top. Interestingly, in those ciliated cells that David's group has been thinking about a lot. There's a lot of stem cell markers. Other folks like Annie Ng and Nick Barker really have characterized this. They're really very similar. And that's sort of the explanation why Nellie and all the folks she worked with could drive some of the high-grade serous phenotypes, but they're probably coming from other places. And for Nellie, one of the last things she published was this to actually show that developmentally, and Diane and I were talking a bit about this last night at dinner. This is a cross-section of the developing embryo. This is the gonadal ridge that will form the ovary, and that ovarian surface epithelium is on the top. And then there's this little indentation that forms these ducts called Müllerian ducts. And that's where the fallopian tubes and the fimbrial epithelial come from. So they have a common origin. And this is how she reconciled this issue with the OSE and the fimbriae. And I know Diane and Nellie had lots of back and forth about this over the years. Jurgen's going to tell us why this all matters clinically and why really figuring out this tissue of origin has been so important and so impactful for so many women with this disease, and is now leading to new treatments. And I will stop there. And thanks very much. And it's so great to see everybody online. And I apologize if I miss anyone. Oh, I see Sandy Orselek there as well. And Barb Vanderheyden's there as well. Many, many people that have worked and collaborated with Nellie. Thanks.
Great, thank you. And so now we're going to, it's a great pleasure to introduce today's speaker, Dr. Jurgen Piek. And I was delighted to hear that he was coming into the neighborhood to go to the SGO meeting, and thought this would be a great time to bring him to Vancouver. As Jurgen mentioned, he came here to meet Nellie and to discuss fallopian tubes and ovarian surface epitheliums after his seminal discovery of the fallopian tube precursors. So Dr. Piek did his medical training in Amsterdam. He then did a PhD. And it was during his PhD when he discovered and described the stick lesions in salpingo-ovarectomies done for BRCA1 and 2 mutation carriers. I'm a pathologist. I entered medical school in 1981. In my career in medicine, I think the two biggest discoveries using old-fashioned pathology, H&E, and careful observation down a microscope were Warren's discovery in 1982 of Helicobacter and its role in gastric cancers, and the fallopian tube precursors of ovarian cancer. Dr. Warren in 2005 received a Nobel Prize. I think as somebody who studies ovarian cancer, I think your discovery is incredibly important, and in that context, as important. Since making that discovery, Dr. Piek has led the efforts to understand and use this information to decrease death and suffering from ovarian cancers through clinical trials, and also for an exploration of opportunistic salpingectomy, which is something we have the privilege of working with him on. So without, I don't want to take any more of your time, and so please take over the microphone.
Thank you very much, David, for the kind introduction, and also for the beautiful day we had together yesterday with the whole groups. Very impressed, and we were very well treated yesterday. Well, I will first show you where I come from. That's a small country in Europe, in the middle of Europe, and that's called the Netherlands, and it's next to Germany and Belgium, and of course the North Sea. And large parts of the Netherlands are -5 below sea level. So we are happy that we've got some good engineers in Holland. We've got windmills for our tourists nowadays. We've got different kind of windmills that take care of the dryness in our country. Of course, the wooden shoes and the cycles, especially in Amsterdam. But for you guys in Holland, we've got 18 million people living there, 18 million people, and divided in 11 provinces. And we have 7 comprehensive cancer centers that take care of the care of women with gynecological cancer. So it's really centralized in Holland. And I happen to work here in Eindhoven. When I started my PhD back in 2000, my tutors, Professor Verheijen, René Verheijen, Kedemans, and Van Diest, they said to me, we want you to do research in ovarian carcinogenesis. And to do that, you need to be able to culture ovarian serous epithelial cells, OSI in short. So that means you need to go to the laboratory of Peter Schwartz and Barry Kaczynski back in Yale, New Haven. So that's what happened. I went down there. And I will show you later, culturing of ovarian serous epithelial cells is basically scraping the serous epithelium, putting them in culture, and then you need to wait. I had a lot of time to spend in the library because instead of how it is nowadays, you couldn't just get your papers from the internet. You really had to go to the library, and they had the most beautiful library that exists, the Harvey Cushing Library, and virtually all journals were available over there. So you went down to look for your journal, look for the volume, copy it, and then you could just read it. And from this study, I learned 2 things. First of all, I didn't understand ovarian carcinogenesis because how could a simple mesothelium, how could that become neoplastic and then become serous and then become cancerous, whereas there is a neighbor that is already serous. And the other thing I learned, if I really wanted to learn how to culture these OSI cells, I had to go to Professor Auersperg. So I called her and she said, Jurgen, tell me about your PhD. Oh, ovarian carcinoma, you need to come over here to Vancouver. And I was like, okay, well, Holland, Vancouver is far away, but New York, Vancouver is short by. So I bought myself a ticket, went down here, and she let me also give a lecture like David does to me right now. And that was very good because it's a good moment to reflect on the things you've been doing. And we had beautiful discussions. And what I really remember vividly is that that she made me think behind the borders of science at that moment. So my talk will consist of 4 parts. And David, I look at you because if I go over the time, tell me I would stop. The first part will be on current treatment. And that's because there's also medical students involved, I've been told, and also the prognosis of ovarian cancer. Then I will highlight the 3 hypotheses of the cell of origin, following by options to prevent ovarian cancer. And then finally, I will touch some future perspectives. Well, there's basically 5 types of ovarian cancer. And most of the ovarian cancers are of high-grade serous. You can forget all of this, but you have to remember that this is about 70% of the cases are high-grade serous. And most of the times, that's also 70+%, these cancers are found in a high stage, which means that the abdomen and sometimes also the thorax are involved. The therapy of ovarian cancer consists of a sandwich, either primary debulking surgery, which means taking out all the tumor you can see, and then 6 cycles of chemotherapy, or first 3 cycles chemotherapy, then the debulking surgery, and then 3 more cycles of chemotherapy. And that depends on the extensiveness of the disease. Well, here you see the abdomen. Here is the symphysis. Over there, somewhere is the xiphoid. So this is completely open. And what you can see over here is the colon transversum. Normally, this would be the omentum, but now it's completely involved by tumor. And we call this an omental cake. And you can imagine if you start to treat this, that this will come with a lot of morbidity. So it's major surgery for the women and also to recover. Well, again, chemotherapy, there's 2 sorts of chemotherapy we give. First of all, platinum-based chemotherapy. Platinum goes into the cell and then it binds to DNA. And with fast dividing cells, when there is DNA damage, this will forecome repair of this damage, thus apoptosis, cell death. And the other one is Taxol, and Taxol stabilizes the microtubuli. So microtubuli, of course, need to pull out of each other these chromosomes when the cell divides. And if you stabilize it with Taxol, there is no cell division possible anymore. Well, these are survival curves, 10-year survival curves from 85 to 2014. And as you can see, we are not doing very well. Most women, and these are all high-stage FIGO, high-stage tumors, most of these women die within 5 years, and 10 years is even worse. Unfortunately, in the time of targeted therapy, we've got new therapy options. One of these therapy options is poly-ADP ribose polymerase inhibitors. Normally, when you have a single-strand break, this PARP will repair this single-strand break, and then the cell can just do what it needs to do. But if you inhibit this, then you've got a chance that you get a double-strand break. If that's the case, in normal cells, a HRR will take place, and then the DNA will be repaired. But if there is no such a repair, and that's the case for women with a BRCA1 and 2 gene germline mutation, these are the women at high hereditary risk to develop ovarian cancer, then this will not happen. That will eventually lead to cell death. These are the progression-free survival curves of women on these PARP inhibitors, olaparib, niraparib, and rucaparib. And you can see that, and these are randomized controlled trials, you can see that women who received this PARP inhibitor do much better than the ones that did not receive it. So we've got a new way to treat it. Well, wrong, because recently we got the results, the long-term follow-up results from the PRIMA trial, also with PARP inhibition. And as you can see, women that were randomized with or without PARP do exactly the same, but in 5 years. But if you recall, the 5-year survival was really bad of these women. And over here, it's 55. So what probably happened in these cases is that women who received placebo during the trial did receive PARP inhibition later on in their treatment. But this is being figured out at the moment, so we will learn this in the next few months. Well, then there's another option for treatment. This is not a targeted option, but it's a possible option to do better. And that's HIPEC, hypothermic intraperitoneal chemotherapy in ovarian cancer. It's a study from the Netherlands in which when we've done the debulking, and here you see pictures of a situation post-debulking, you see the intestines over here, we make a so-called colosseum. And so this is how it looks like. And then you put tubes in there, and then for 1.5 hours, we put heated platinum-based chemotherapy in there. And of course, during the chemotherapy, we will completely cover it. And does it work? Well, it does. 5-year survival, randomized controlled trial in the Netherlands, 300 people, women who received the HIPEC do better than the ones that didn't. But recall these 10-year survival curves I just showed you before. These are the ones from up till 2022. Well, despite these new therapies, we're not doing that much better, as you can see from this graph. Well, then, the hypotheses. I think a lot of people of you came for the hypotheses. So there's these 3 hypotheses, and this is the ovarian surface epithelium. I put this behind brackets because it's not an epithelium, but it's actually a mesothelium. And the whole idea of the origin of the ovarian cancers from the ovarian surface epithelium comes from Mahmoud Fatala. Mahmoud Fatala was a gynaecologist from Egypt, also the former president of the FIGO. And he says, because of these these ovulations, you get wounds, and these wounds they need to be repaired. And during this reparation, there's of course you've got mitotic activity, and when you've got mitotic activity, then you get DNA damage, thus also a high risk on ovarian cancer. And in nuns, women that ovulate consistently, you see a high incidence of ovarian cancer relatively. And one of the articles he refers to in his 71 paper is a paper by Wilson, and he looks at domestic foals. And after 3 years of ovulation, you see all these domestic foals, or at least almost all, to have ovarian cancer. So the whole idea is that these flatucubiidal cells, they get, and you see them here under the light microscope. I love this picture, the stroma, and this is this surface epithelial cell layer. They get included into the ovary and then become serous and ciliated. So again, this, and then you see this is such an inclusion cyst with ciliated cells, and the serous cells are positive for BCL2. This is the BCL2 staining. You get dysplastic areas, and then finally you become a carcinoma. Well, if you want to study this, then you want to study it on a high-risk population. And a high-risk population are women with their breast cancer 1 or 2 gene germline mutation. These women have a high risk on ovarian cancer, also on breast cancer. But if these ovarian surface epithelial cells are prone to develop into a malignancy, then you could just use them in the cell culture. And that's what Nelly did a lot. And it's fairly easy. This is a situation where the operation is because you remove these ovaries and tubes at a certain age to prevent ovarian cancer from happening. And during this operation, you scrape the surface, you put it in culture. This is such a culture flask, and this is the T25, I guess you called it, isn't it? Flask. Oh, I've been using them as well. And then if you leave them and they senescence, then you see actually 4 types of cells. You see cobblestone pattern. This is the typical pattern you see with these ovarian surface epithelial cells. You see atypical epithelium. You see, in my opinion, fibroblasts. Nelly called this epithelial to mesenchymal transition. And you see swirly cells or tubal epithelial cells. When I started my PhD, Nelly had already 36 articles on her name with the ovarian surface epithelium. So she was indeed the guru. So I was here at the right place. I just showed two articles, and as you can see, these are these articles. I just photocopied them in the Harvey Cushing library. And if to summarize the study from Patricia and of course from Nelly, basically oozy culture from women with a hereditary high risk to develop ovarian cancer are not phenotypically the oozy cultures from controls. Well, then the second option, and this option comes from Louis Dubois from Los Angeles, and he postulated that because these there are some remnants, embryonic remnants within the females, these might also become neoplastic in nature, and you have to. It was already touched a little bit, but during embryogenesis, you've got the Mullerian tube, and the Mullerian tube fuses and creates the fallopian tubes, the uterus, and the upper 2/3 of the vagina. And you can imagine if this fuses, then you must also sometimes have remnants. And in these, you can find these remnants, for example, in the hilus of the ovary. This is the ovary. You see the follicles, and the hilus, you see what's called the reti ovary. And if you look closely, then these are all serous cells. Of course, they can also become malignant and cause high-grade serous cancer. Well, and then finally, the tubal epithelium. First, a bit about oozy. The studies that Nelly performed just parts of them. We also performed them in the laboratory, and we tried to see whether we could copy this data. But despite all our efforts, because we really wanted to copy the data from Nelly, we could not. The research that we performed showed that ovicultures derived from women with hereditary high risk to develop ovarian cancer have the same phenotype as the control group. And I showed you those fibroblastic-like cells, and I just think, and I will show you here, this is keratin 7 and 8 staining. I love this picture, by the way. But you see these cells, these are ovarian surface epithelial cells, but in between you see these keratin negative cells. And I just think once you scrape the ovarian surface, you just also get some fibroblasts, and they can just also, of course, grow in the medium. Well, Nelly wouldn't be Nelly if she did not respond to our article. And or you can read, perhaps Piek failed to detect these differences because they did not examine primary cultures, did not take into account the reversibility of EMT, and attained fewer population doublings in their ovicultures. We'll get back to this a bit later. Well, over here you see a sample of a prophylactically removed fallopian tube and ovary, and you see these follicles over here. These are actually paratubal cysts, which are normal, so that's not pathological. You see the gyri here, it's beautifully in the ovary. Well, together with one of my promoters, Paul van Diest, nowadays he's professor in pathology in the University of Utrecht, we started to study both the ovaries and those fallopian tubes of women at high hereditary risk, most of the times BRCA1 and 2 gene mutation carriers. And this is also a BCL2 staining, again, serous and ciliated cells inside the fallopian tube. But sometimes we encounter this kind of areas, and we're, okay, you know, this can be a problem with how we process these areas or whatever, but we were like, you know, but then when you see this in a fallopian tube, you're like, no, this is wrong. This is really wrong. We stained it for Ki67, which is a proliferation marker, and we found them in the initial group of patients. We found this kind of dysplastic lesions, as they were called at that time. We found them in about 50% of the cases. I micro dissected these kind of areas in multiple tubes, and what we found was that, in this case, a BRCA1 mutation carrier, we found loss of the wild-type BRCA1 allele, which means that the first step into ovarian carcinogenesis is loss of this wild-type allele. Furthermore, to mimic the retrograde menstruation, when you menstruate outside, but of course the tubes are open connection with the abdomen, also sometimes a bit inside. And we started to mimic this, and this supernatant I just collected, put it in culture, and you got this nice furry kind of cells. And remember, the ovarian surface epithelial cells, sometimes when we scrape the ovarian surface epithelium, we found this. And here you see again the BCL2 staining of a normal fallopian tube, and this is again one of the examples of these inclusion cysts. Serous cells, but also ciliated cells. And then it was like, okay, are they truly metaplastic, or are they just derived from the fallopian tubes? And since serous tubal carcinoma and serous ovarian carcinoma are phenotypically indistinguishable, it's just by matter of discussion that you say it's a tubal carcinoma because the bulk of the tumor is in there. And these ovary and the fallopian tube make, of course, very close contact to each other. And in fact, if you've got a stigma, which is the situation after a follicle rupture, that's, of course, an area where these cells can really nicely grow, I guess. And again, to come back to the article of Mahmoud Fatala, Wilson, it's that it states tumors in the oviduct, so which is another name for the fallopian tube, were always larger than those in the ovary. So that's something Fatala didn't tell us. So now you guys spot the differences. Which one is true? So this is where we were, how we were thinking about ovarian carcinogenesis. I think this is the most likely case, and research from all over the world does show that as well, which I will show you right now. But in 2004, I have to say, I published my thesis, and I show you this one because first of all, we also postulated the so-called atom theory, and I also sent a copy, of course, to Nelly. And at that time, with the internet not as advanced as now, we had problems with finding each other's email address. So Nelly sent a fax. I don't know if you guys know what a fax is, but to Professor Verheijen. And she congratulated me. But as you well can imagine, I do not agree with your conclusions. We in 2004, I wrote down these hypotheses. In 2003, we wrote, we postulated that BRCA mutated ovarian cancers are of tubal origin, and then later on, also in 2006 and 2007, we did the same. Well, very crazy, because what I didn't tell you yet is that these fallopian tubes and ovaries we were looking at most of the times at Friday afternoon with a bottle of beer and Meridian in the background with Professor van Diest. And we might have just been delusional, but we are not, because the group of Christopher Crum, they came up with this article in 2006, in which they looked at dysplastic lesions in 13 fallopian tubes from women with and 13 from women without a high hereditary risk. And in 5 of these cases, they found a stick lesion in the high hereditary risk cases. And because these lesions are so small, they also came up in this article with a new protocol, the so-called C-FRIM protocol, serial sectioning and extensively examining the fallopian tube. And I think that's being used right now worldwide. And that's why we find many more sticks at the moment than we did before. Well, even Louis Dubois, together with Ronnie Drakeman, published in 2013 an article on this topic. And now you can see, this secondary Mullerian system again, in the hilus of the ovary over here as well. But now they color the fimbria red as well. And even Nelly published an article in 2013 even. And I love this picture as well because it's E-cadherin staining in the fimbrial part of the fallopian tube. And she shows that in the ovary surface epithelium, there's no E-cadherin staining, but some areas there are. And one can, of course, argue with each other whether this is a metaplastic area or maybe it's just outgrowth of this E-cadherin positive tubal epithelial cells on here. Well, for so far now, the 3 possible cells of origin, I think at the moment, most people in world go for the tubal epithelium related hypotheses. So if that's the case, then we might prevent ovarian cancer. Well, Ramlogan Chowamba really eloquently put this in a review that when you remove the fallopian tubes of women at non-hereditary high risk, so this is in the general population, and we call that a so-called opportunistic salpingectomy. You remove it when you've got the opportunity to remove the fallopian tubes because you do other surgery, for example, hysterectomy or tubal sterilization. Then when you take that away, you can prevent the majority of high-grade serous cancers. And Ramlogan even goes further because you can probably also prevent endometrial cancer and also clear cell cancer. But if that's the case, if you remove the fallopian tubes, then you should see a diminished risk or diminished amount of cases of ovarian cancer in these groups. And there's some large cohort data studies, which I will show you right now. One from Denmark, rather large, and you see that when you've got a bilateral salpingectomy, you've got a 42% risk reduction on ovarian cancer. And the same kind of study from Sweden, from Henrik Falconer, you see a 65% diminished risk on ovarian cancer. Then our own Dutch data, I have to be honest, because this is from the Dutch pathological database. And at this, when we published this 4 years ago, there was the time from research to a possible moment of developing cancer was not that long yet. And so this is not significant yet, but so this is women who've had a dermal nevus, so that was the control group. And these are the women who had the salpingectomy. And although it's not significant, you see that these lines follow each other. And now we're in the process of going through the data, but then up to right now. And then finally, data from here. I love this study. It's a study from a little less than 30,000 women who underwent opportunistic salpingectomy during hysterectomy or during sterilization procedures, compared to a control group of a bit more than 30,000. And what Jillian saw is that she saw 5 cases of ovarian cancer, and none of them were of high-grade serous histotype, whereas about 10 would have been expected. So that, in my opinion, is a very clear indication that it works. Well, if you start to do preventive surgery or whatever kind of prevention, then you should never do harm to the patients, because it's a prevention of something. And that's where I want to touch right now. By the way, I don't like the word prophylactic salpingectomy, because in my opinion, prophylactic surgery should be reserved for women at high hereditary risk. So it's an opportunistic salpingectomy that eventually, of course, prevents cancer. But so we did some research in this field. It's old research, so we need to update it. We're actually also in the process of updating this database that Laura von Lieshout did all this work. Should be noted that the data you see over here is of low evidence because of the small numbers. She looked at women who had a hysterectomy versus women who had a hysterectomy with opportunistic salpingectomy. She looked at intraoperative complications, postoperative complications, no difference. Also, data from here that really substantiates this data as well. These are women who underwent hysterectomy alone or with OS or tubal ligation or OS instead of tubal ligation. And you see that there's no difference in all these parameters which are related to complications. Well, now some anatomy again. The vagina, the uterus, the fallopian tube, and the ovaries. So the vagina and the uterus get their blood from the internal iliac artery, but the ovarian artery comes from the aorta. And if you do this preventive surgery, you want to remove the complete fallopian tube. And if you do that, you also kill some of these blood vessels. So there are some people who are afraid that once you do that, that you might change the microcirculation within the ovary. And there is, of course, follicles. And follicles are very sensitive to oxygen problems. So if there's less oxygen, you might also get necrosis of these follicles, and then you might also get into premature menopause. Laura also studied this, and she studied it with AMH concentration, anti-Mullerian hormone concentration, and which is a surrogate marker for the ovarian research. And what she saw is that there were no differences between the groups, though it's borderline not significant. But then, of course, there would be some data from here, from Canada, which is also very solid. And what Gillian did in this case is she looked at time to hormone substitution therapy, and in 3 different groups. In a group of women who underwent hysterectomy with bilateral salpingo ovarectomy, so the ovaries were removed as well, then you can see that a lot of these women asked for hormone substitution therapy, whereas women with hysterectomy or hysterectomy with opportunistic salpingectomy are overlapping, indicating that there is no difference in these 3 groups. Well, this is a study from Miranda, also a bit older data, which has been updated. I will show a bit later. If you want to implement a strategy to prevent something, in this case ovarian cancer, then you should give all patients the opportunity to choose for themselves. So all women should have the opportunity to choose whether they want to have OS or not. Well, this is data from 8 different hospitals, and you can see that during hysterectomies, OS was discussed quite often and performed also quite often, but during vaginal hysterectomies and sterilization, actually virtually never. So no way that women could choose for themselves. That's why we performed a barrier and facilitator study. We looked at options to increase this uptake of OS in the Netherlands, and barriers were the low lifetime risk in the overall population. So I'm not talking about the high risk population, but I'm talking about the low risk population. The knowledge on the procedure, the possible effect on the age of menopause, the unknown risk reduction, and whether it was feasible or not. And facilitators on implementation were, of course, the high mortality rate, as I showed you in the beginning, the risk reduction, whether there was a family history of ovarian cancer. The fallopian tubes do not have any function anymore, as far as we know, after you've finished your family. The availability of counseling material and whether there is a guideline or not. And in the Netherlands, fortunately, now it's like since 2 years in our guideline. And for counseling material, and I ask you to just grab your phone right now for the clinicians. We developed a patient decision tool, because when you're in your outpatient clinic and you talk to your patients, then talking about this subject, of course, complex, is not easy, and you only have 15 minutes. So you want to talk about something else. And that's why we made this decision tool. It's translated into English, in German, and of course in Dutch, and we hope to translate it in other languages soon as well. And this is a QR code, so you can just use it at your own discretion whenever you want. And I guess for us, it really works. You just tell your patient, okay, go to this website, they go down there, ask some questions, they will fill out some questions, and then a few days later, the nurse will call them and they write it down in the notes, and that's it. Unfortunately, in the Netherlands, as you can see, there is an increase in uptake, but it's not in the 70s or 80s. So there's some work for us to do, guys. Well, then at the end, I want to touch on some future perspectives. First of all, this is a large study. It's a study about 5,000 women that have to be included, women who undergo hysterectomy, and they are randomized on hysterectomy alone or hysterectomy plus an opportunistic salpingectomy. I mean, the enrollment is still ongoing, but I question whether this is still ethical with all the data we have at the moment to withhold women from the possibility to undergo OS. And but this will eventually be, because it's a randomized controlled trial, will give us the most solid data you can have on the the preventive work of OS. Well, then in Holland, we also try to have another look at the effect on the ovarian reserve. We do that in the Stop of Cayong. All women who undergo a sterilization are asked to enroll, and they get a questionnaire every year, 2 or 3 minutes. They fill out things about their cycle, whether it changed. Of course, we look at the age of menopause. Another thing we are trying to perform right now, and also to look at the feasibility at the moment, is and that's called Tomasino and Graz, who first started with it, is trying to implement OS during non-gynecological abdominal surgery, for example, cholecystectomies or bariatric surgery. And another thing we are busy with is trying to roll out OS throughout Europe. And we do that via the European Society of Gynecological Oncology Prevention Committee, and to make a guideline European-wide. And then finally, Canada is already in, United States is already in. Of course, the Netherlands is in, and also Austria. We're really looking forward to create United Nations of the opportunistic self-injectomy. I want to thank my collaborators, Janne de Hulu, Rosella Hermans, Dr. Steenbeek, and then our PhD students, Charlotte Fisch, Jolijn Schouwarts, and then we have the 2 students who were already defended their thesis already, Laura van Liesert and Marloes Gelderblom, and of course, Tama Gootsens, she's also over here, and I want to thank you for your attention.
Thanks so much for providing this amazing bridge between Dr. Alsberg's work and your own work in the future. So we can open this up to questions now. We'll start with, are there any questions from the audience? Amira has a microphone. And oh, great. So Dr. Hanley.
Thank you, Jurgen. Great talk. One thing we've been encountering a lot when we're trying to roll out to general surgeons is real hesitancy among the premenopausal patients, because people are really concerned about regret. And so your comments around it's important to let women make this decision for themselves really resonated with me, because I've been trying to have similar conversations with general surgeons here. Have you had any success sort of convincing people not to be so terrified in the premenopausal population? We do have data that suggests about a 15% regret rate with bilateral self-injectomy for sterilization. So it's not an unfounded concern.
Yeah, I agree with you. The first remark about the surgeons, we are actually in the process right now. And the surgeons with whom I work closely together, they are really willing to put forward this. And at the moment, we are also making material to show other colleagues how to do it. The second, and you're right about the regret, the decision regret. I think it's most of the time it's women below the age of 35 who have this regret. So
or people who change partners. Those are the 2 most significant.
Yeah. So. But this is something that's also part of the questionnaire, that the online questionnaire people get. And then, of course, I mean, you can only do so much. You have to inform them. The other side is if they develop ovarian cancer later on, then that's a different story.
A different kind of regret. I use that line of reasoning often as well.
Yeah. So. Is that an answer on your questions?
Yes, thank you.
I'll give it to Diane first, because it's going to be another clinical. Then I'm going to ask a basic.
I think it's great to be expanding to general surgeons, but looking at your data, you haven't reached half of the gynecologists, and that's where the real money is going to be in terms of prevention. It's a bit surprising because in our area, the gynecologist came on board very quickly. So what do you think the barriers are for the gynecologists in the Netherlands?
Well, it is a very good question. The problem is the counseling, I think, because it takes time. That's why we've got this decision tool now. And the other thing is that it's just recently in our guidelines. And now, actually, if it's in the guidelines, I don't know how it is over here, but then in the Netherlands, you really need to discuss it at least. So my colleagues in Holland need to discuss it. And virtually all conferences where we touch this subject. So by basically brainwashing our colleagues, hopefully, the uptake will be better in another 2 years. And I think it will be because of the guidelines, etc.
So Jurgen, just to go back to the basic science stuff and the various hypotheses, but moving forward from the hypotheses, presumably coming out of the stick, you can still have some of this egress and moving on to the ovary. Do you think that this was one of Nellie's, I would think, folks, one of Nellie's big hypotheses. There was something in the microenvironment of the ovary that was helping facilitate progression. Do you still think that's the case, or is there any evidence of that?
You mean that, for example, the follicular fluid, that there is something in there that might. It's interesting because if you look at the precursor lesions for the sticks, we believe it's p53 signatures, if you look when they arise, that I think that would give maybe an answer on your question. So I think we should not look at sticks. We should look at the pre-sticks, so the p53 signatures. Yeah. Well, yeah.
If anybody online would like to ask a question, please type it in the chat or raise your hand and we will try to connect. Okay. I think we're going to have now, after this talk, Dr. Piek and his colleagues are going to meet with the trainees, which is going to be a wonderful opportunity for them to continue their learning. But now we have a very special opportunity to say thank you. And Maria Auersberg and Dr. Deborah Money would like to say a couple of words to you in gratitude for you launching the Auersberg Lecture Series in such a spectacular fashion. And while they're coming here, I just would like to acknowledge Michelle Wu and Julianne McLeod, who really did all the heavy lifting to make this fantastic event possible. So thank you.
So thank you. I really can't think of a better speaker to have come to start off what we hope is going to be a series in honor of Dr. Auersberg and her amazing career. We really feel that at UBC, we need to be doing these kinds of things to recognize individuals who've made huge contributions. And you gave us a wonderful talk and a great perspective on this entire area of research. And we're very grateful to you for coming. And we have a small plaque and even a little UBC pin for you in remembrance of your time here.
Oh, thank you.
So that's going to fall off. You want to put Excellent. Okay.
Thank you so much.
Maria, do you want to come up? Oh, sorry, the pin. I know. Thank you. Thank you. I wonder if you could put up. Yes, thanks.
So Dr. Piek, Jurgen, if I may, I just want to say thank you on behalf of everybody here. And Michelle asked me a while back if there was something that an Indigenous gift that my mother would have liked. And she always loved very simple Inuit carvings, because she taught me long ago that the simplest things can be very evocative and display great emotion. And Michelle went out and looked for things and came across this print. And I think, David, it resonated with you and with me and with Michelle. And both Michelle and I both thought, why does this make us think of my mom? Why might it make any of us think of my mom? And the first thing I thought about is she loved animals, she loved birds, she loved simplicity. On the surface, it's rather amusing because the animals have the upper hand, and she would have liked that. But it's called The Legend of the Loons, and there's a limited edition print. And David Yaluk Amitu is actually a really well-known Inuit carver, and later in his life, he was a 20th century carver, became a printmaker, and he was most known for storytelling. And this is actually The Legend of the Loons, if you should look it up. A serious and a haunting and a beautiful story of loons who healed a blind child. And it's a story that evokes huge imagination and a trust to follow your instincts for the sake of healing. So all in all, I think it makes a fitting thank you to you. So thank you.
I think at this point we can close this session. I want to thank everybody who's attended today for making it so special, and the amazing online audience, which includes so many of Dr. Auersberg's past trainees and collaborators, and also her family. Thank you so much for joining us today. So thank you, and enjoy the rest of your day. Thanks.
Dr. Handling has to be there. With Jurgen. With Jurgen. Like do that research, yeah. I think that's the way to go. Always showing you with you the way ecology database, and that way working, we can get everything out of it.